everyone, and welcome back to the channel. So in today's video, we're going to be learning about one of the oldest encryption technique used for sending secret messages, and actually one of my favorites. So it was first used by Julius Caesar to send messages whenever he was at war. So that is why it was named after him, Caesar Cipher. So how it works is you shift the letters of your message. All right, and what makes it interesting is that the shifts you can use are dynamic. Take for instance a word like cat. All right, let's take a word like cat. So cat, take a word like cat. All right, so for cat we're going to say we use a shift of 3. All right, and what does this mean? It means you take every letter of the word and you switch it for the third letter after it. So for cat, we are going to say D, E, F. So we use F. And then for A, B, C, D, we use D. All right. Then for T, R, S, T, U, V, W, then we use W. So if you shift cat 3, if you specify a shift of 3 for cat, you get FDW. All right, so let's also do for another word. Take for instance hello, and also let's do a shift of 5. All right, so for a shift of 5 we say IJKLM, so you get M. All right, then for E you get FGHIJ, you get J. Then for L you get MNOPQ, of course Q 2 times. Then O you get PQRST, so you get T. So if you specify a shift of 5 for hello, you get MJQQT. All right, so now let's write a program to see how this works. It basically works like a loop, right? So we wrap and we specify the number of shifts. So the first function we're going to write is the encryption function, so which is what we convert our original message into the secret message we want it to be. So for encrypt we do def encrypt, and then we want to pass 2 arguments to it. So text, which is of course the text we want to pass, and the shift we want to specify. So I'll simply say shift, I'll say shift value. All right, so shift value. Then we create a variable called results. It's an empty string, and then we loop. So we say for each character in text, right? For character in text, what do we want to do? We check if the character is an alphabet. So if character dot is alpha, right? If character is alpha, we say base should be equal to odd. I'll pass uppercase A to it. Odd if char is upper, character dot is upper. Don't worry, I'll explain what everything means. Else odd lowercase. Odd lowercase. Then what else do we want to check for? So we now see the new character, which is now our encryption, right? So we say new character should be equal to character in the order. Character. All right, minus base plus shift. So we're applying the shift to each character, then shift, okay, I say shift value not just shift value mod 26, which means the 26 alphabets in the English, the 26 letters of the English alphabet, mod 26 plus base. All right, so the results which we declared earlier as a variable will now be plus equal new character, which of course, like I said, is now our encrypted character. So else what do we want? Results plus equal character. All right, then what do? We return results. So what are we doing basically? Like I said, we check if the character in the word, we first look through the each character in the text, right? Take for instance cat or hello. So we loop through each character or letter in the text, then we check if the character in the text is an alphabet. Then after checking for that, this base here, what it simply does, it checks if the character is uppercase. It keeps it as uppercase. All right, then let me show you. It returns a Unicode point for a 1 character strings. What it basically does is, if the character is an uppercase, it makes it remain uppercase. Then if it is lowercase, it keeps it as lowercase. All right, so this part here in new character is what handles the wrapping, right, from A to Z. So now whatever the result is will now be the new character. And like I said, new character is the encrypted word. So now let's come out and see the usage, right? So I'll say print encrypted, print encrypt, let's pass hello. So it's hello, comma, and let's use 5, which was what we did earlier. There is problem. Is alpha. A string has no attribute object, is alpha. Did you mean is oh sorry, I made a mistake here by saying is alpha uppercase. Okay, so let's rerun the program. So you see, as we saw earlier, MJQQT. But by using this base here, you see it kept hello, which is uppercase, it kept it as uppercase, which is the M. So but the rest are lowercase, and it kept them as lowercase. Now if I should duplicate this, Command Shift D, and oh wait, I think good. So now I cannot duplicate it, and I'll say uppercase LLO. And of course, when you run it now, you see MJQQT like we saw here. We can also check for cats. So I'll say print encrypt cats, encrypt cats. Then I'll pass 3 to it. Then I'll pass 5 to it again. So when we run it for 3, you get FDW as we saw earlier. But then for 5 shift, you get HFY. So if we write a message like this, we can now say print hello cat, right? So I'll say print encrypt print encrypt hello. I should put this inside. Hello cat. And we shift by 5. All right, so if we shift by 5, you see we see MJQQT HFY. All right, so we've encrypted the message. Now I'm going to write a function that makes it easy to decrypt the message, right, so that we can convert it back into something we can read. And it's actually a very simple function. Since encryption already handles all the shifting and the logic and the wraparounds that we've done, we simply just have to shift to the opposite. All right, instead of adding, we subtract. So I'll simply say decrypt def decrypt. I'll give it the text and also the shift value. So we'll simply say return encrypt. All right, we simply make use of encrypt, so pass text to it, and like I said, we subtract. So I'll say minus shift value. All right, so now we can use that decrypt method. So I'll say print decrypt. So for decrypt, I'll also pass hello cat to it. So we say hello cat in, we decrypt by 5. Oh, sorry, I should pass whatever we did here. I should pass the result of encrypt. All right. So I passed the result of the encrypted message. So you get hello cat. So we convert it back from the encrypted to the original text. So let's do it the way Cipher, what's his name? Julius Caesar would have done it. So I'll simply say, imagine Julius Caesar sending message to his commanders. We say attack at dawn. Attack at dawn, or should I say attack at dawn with the rising sun? Let's just make it rhyme. With the rising sun. Alright, so we encrypt. We want to make it very secured, so we encrypt by 10. Now let me run the program. Attack at dawn with the rising sun. So I'll copy this, Command C, and I'll paste it here. Command V. So this will be from encryption. Will be from encryption will be from Julius Caesar himself. Will be from Julius Caesar himself. So when it gets to the commander invokes our decrypt method. So Julius Caesar invokes the encrypt. He wrote this message and he encrypted it. So the commander or the general, his general, will use our decrypt method. All right. So when we run the program, you see Julius Caesar encrypted his message. So the general got this, and then the general decrypted the message and he got what Julius Caesar actually wanted to say. So we can write a simple user interaction to make this more interesting, right? So I'll simply say choice should be equal to input. So we want to take user input. We'll say either you want to encrypt or decrypt. So we'll say encrypt, so user will press E. All right, then decrypt, user will press D. So we don't want to stress the user can press lowercase, we just want to make it upper. All right, so make it upper, and then what do? We ask for the text. All right, so we say text should be equal to input, enter your text, all right, so the user will enter the text, and after entering the text, we ask for the shifts. And remember, in Python, input by default expects strings. So if you're going to enter any other data type, you need to typecast it. So we typecast it to integer. So we say input, enter the shift amount, or specify the shift value. Specify the shift value. Why am I writing like this? Specify the shift value. All right, so it allows the user to specify the number of shifts they want to enter. So let me now use the if statement. I'll say if choice is equal to E. All right, so we want to encrypt. Print f string encrypted message encrypted message, so I'll simply say encrypt text. Encrypt text, comma shift. All right, then else if choice, else if, is it else if or elif? Okay, elif choice is equal to uppercase D. Then we'll say print, using the F string, that's the print decrypted message. Now say decrypt text, comma shift. Else print invalid input. Invalid input, all right, or invalid choice, whatever. So let's just run the program now. So it will ask us, do we want to encrypt or decrypt? I want to encrypt, so I'll say E. Then enter your text. I want to enter hello. I specify shift value, I'll specify 3. So the encrypted message is KHOOR. So that's all for this video. You've learned about how to write programs and also how to implement the Caesar Cipher. Of course, this is a very basic program. You can expand it as much as you want. That's all for this video. Thanks for watching, and I'll see you in the next one.